How capacitors work in electronic circuits. Welcome to this presentation on how capacitors work in electronic circuits. Today, we'll explore the essential roles capacitors play, from energy storage and filtering to coupling and timing applications. What is a capacitor? A capacitor is a passive electronic component made up of two conductive plates separated by an insulating material called a dielectric. Its main function is to store energy in the form of an electric field. Capacitors are widely used in electronics for various purposes, making them a fundamental building block in circuit design. How does a capacitor work? Charging phase. When a voltage is applied across the capacitor's terminals, electrons accumulate on the negative plate, while positive charge accumulates on the positive plate. This creates an electric field between the plates. The relationship between the charge stored and the voltage applied is defined by the formula Q equals C times V, where Q is the charge in coulombs, C is the capacitance in farads, and V is the voltage in volts. Fully charged state and discharging phase. As the capacitor charges, the voltage across its plates gradually approaches the applied voltage, and eventually, current flow stops. The capacitor holds the stored energy. When connected to a circuit path, it discharges by releasing this energy, allowing current to flow in the opposite direction until it is fully discharged. Key roles of capacitors in circuits. Capacitors serve several key functions in electronic circuits. First, they act as energy storage devices, temporarily holding electrical energy. Second, they are used in filtering applications, where they smooth out voltage fluctuations in power supplies. Third, capacitors help in coupling and decoupling signals, allowing alternating current to pass while blocking direct current, or removing noise from power lines. Finally, they are integral in timing circuits, where they control time delays in applications such as oscillators and timers. Example: RC charging circuit. In an RC charging circuit, the voltage across the capacitor doesn't increase instantly. Instead, it follows an exponential curve given by the formula Vc of t equals source times 1 minus e raised to the power of negative t over Rc. Here, the Rc term is the time constant, which determines how fast the capacitor charges or discharges. This behavior is fundamental in designing circuits that require precise timing or controlled signal shaping. Summary. In summary, capacitors work by separating charges and storing energy in an electric field. They are versatile components used for energy storage, filtering voltage, coupling and decoupling signals, and controlling timing in circuits. Their behavior in RC circuits helps illustrate the elegant exponential nature of charge and discharge dynamics. Thank you. Thank you for your attention. I hope this presentation helped you understand the fundamental operation and applications of capacitors in electronic circuits. Feel free to ask any questions.